Going. So we're going to be working on admin of code problem 12, and we're going to dive right in. So I'm pulling up the page right now for the first time, and we're going to go ahead and copy this text. We're going to create a new file sort of based off the name of the problem statement, and then copy the text and start to cut it down. So let's do that. And then I like to put in the problem number as well. All right. Let's go ahead and get all of it. As well as comment it out, and then also before we start reading, create a new file in our resources directory with our new input, so we can refer to that as well, and then we can get rid of this screen for the time being. So I'm going to save this as rain risk input. All right, now we can move that off and just use our editor. All right, day 12. So last time we were doing a seating arrangement and for the ferry. So now we're on the ferry and we're moving along. The ferry made decent progress toward the island, but the storm came in faster than anyone expected. The ferry needs to take evasive action. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safely, it produced an extremely circuitous instructions. When the captain uses the PA system to ask if anyone can help, you quickly volunteer. I sense a theme of us volunteering for things mechanically related here. The navigation instructions, your puzzle input, consist of a sequence of single characters actions paired with integer input values. Okay. After staring at them for a few minutes, you work out what they probably mean. And then action N means move north by the given value. Action S means south by the given value. Action E means east by the given value. W means west by the given value. L, left turn. R, right turn. F means move forward in a given direction. Man, this feels familiar. Am I in the right one? Hold on. It just feels so familiar. Yeah. I just feel like we... It feels like another one that I saw. I guess maybe not. Action F means move forward in the given direction the ship is currently facing. The ship starts facing east, only the L and R directions change the direction the ship is facing. That is, if the ship is facing east and the next direction is... So L and R only change the ship's direction. Facing east and the next direction is 10 north. The ship would move 10 units north but still be facing east, so it the ship just like teleports without changing. Like if I'm facing this way, then I just start strafing, like the ship strafes. Okay. These problems, and they try so hard to write a story and then they don't actually care, and then it comes into the algorithm and it just makes it so awkward. So unrealistic, right? And then the storyline is like literally just there to annoy you, because if it was a real problem, you know, it would be much more complicated for one. Anyway. But I mean, we know what they're saying, right? Like, if you're here, and this is north, and let's always have the ship be like an arrow.
and this is east. If you get an instruction that's 10 n, and let's say each one of these is 5, whatever. I mean, the point is you're going to end up this way, and your direction is still east.
And then they give us a series of instructions. At the end of the instructions, the ship's Manhattan distance, the sum of absolute values of its east and west positions and north and south positions from the starting point is 17 plus 8 equals 25. Okay, so this would be the starting position and ending position. Okay. Simple enough. Kind of want to keep all of this in counts right now. And then here's a set of examples. I'm going to put these in a file too, because that way we can just do the exact same thing as our problem requires. Union risk example input. I'm guessing some people would like to create a function that, you know, reads an input every time, and that's fine. Let's just do this for now, because we might be moving around quite a bit. Oh, and we'll need to, if we already started a REPL, we'll need to quit it. No, we wouldn't have. I thought I needed to add resources to the path for a moment, and I don't. I wish I had autocomplete on my file names, because any chance to not make a typo is welcomed. But for me, these couple lines of typing here aren't because you might not always want a string split depending on the input. It might not be per line, so you just kind of, IO and slurp, you could make into a function, but otherwise everything past that is pretty open-ended. And even slurp is like, right, because if they gave us an input, it would have to be a huge input, but they could, that you wanted to do lazy. You wanted to load, yeah, that would be pretty rare. But theoretically, you might have to break that. So, so we want a string split here too. And then it's the string, and then our regex, which is going to be pound symbol. And then we want a string split on nothing. Open needs to be a thread last. And for the moment, let's have it out here. Oh, because I didn't make it a function. Oh, it wouldn't be straight split on nothing. It would be on the first character. So just do partition, I guess. No, what I could do is just do structuring on a string. So that would be direction, and then everything else would be value, and I would do direction, value. integer. Number format exception. Let's see what I'm just getting right now for direction. Oh, because I didn't, I need to break it up. And then they write down these are characters. Is that fine? I just don't like characters. I just don't like them. That doesn't help. How do I turn a, I thought you, I just want to turn these characters into keywords. Because keywords are just a little bit more, you can use them as functions and stuff. So I guess I gotta do this to a string, and then a keyword. I mean, I don't think this is gonna, this would not be very performant. You would not do this if it needed to be, the input reading needed to be super fast, which I sincerely doubt will be the issue here. But if it is, just a couple changes. New meshing. C to our class. So what is our value currently? Is there a better way to do this? It would always be a list. If there is, I'm not going to worry about it because I know what to do here. Separator. It's just a little bit more work than I had thought when I came into this. Is that gonna work? 11. Okay, it does. Right, this looks good, everyone. Comment thing aside. 3, 7, 9, 11. So for now, let's put that. Let's go for it. Let's make a function, right? We're here. We're here. We're doing it. Input to direction to value. That's F. And then plunk this guy in here. And there's a thing called promote to function, and it's because I typed, I'm getting an error because I typed def instead of defn. It was a def. I forgot to update it to a defn. Great, that looks correct. We can get rid of this for example, that's kind of noise now. And I just realized I want to do one more thing here. Oh, it's not direction. It's action, because it's not directions. There's a thing with my rename that's not, didn't kick on. I might restart my editor, because something's not Something's not working as I expected. So this needs to be action, and because left and right are not directions. Okay, this is why rename would be helpful. Should have done that at the start. And one more thing we want to do here is I want to do this. Do I? I mean, left, right, these keys are pretty... I don't like single characters when they're easy to mix up, but here it's really debatable whether anyone's going to confuse East, E and W for anything other than East and West, or L and L, R and forward. Yeah, these are all fine. I'm not going to bother making... because I would... You know, being more verbose is better if it's going to save you time from squinting later. And trying to remember, like, is this R for ready or for reverse? Just, you don't want that problem, because that's you know, you're having that problem just because you didn't run around at 3 characters and all of a sudden there's a huge bug. Okay. So the ship starts by facing east. So our initial starting position, where do we, like, I assume we have, like, some sort of like XY coordinate location, but it's not mentioning that. To east 10, north 0. I'm reading this instruction here. F10, this is the first instruction. Would move the ship 10 units east. Because we started facing east. And to east 10? What the heck is east 10? Right? That's not how... I guess so. It's just conflating things a bit, because that's east is a direction relative. So you could never tell somebody I'm at 10 east and they'd be like, 10 east of what? 10 of east? And you'd be like, at 10 east of where I started, you idiot. And you're like, but I don't know where you started. And you're like, I started at less than 10 of east. And they'd just hang up the phone. They'd be like, you're a silly person. I do not want to talk to you anymore. I don't know, so this is what they're saying. Is this enough for... Yeah, let's say we start here. So, I don't know how much I'm going to draw out here, but, and then if our first instruction is forward 10, then 1, 2. So we start at 0. So this is 5, and this is 10. So we set it up here. This is east. And then ship would face. And then if you add 3, this would be 3, so 0, 2. And you see, like, if we stopped right here, the Manhattan distance would be, I guess, this distance, right? Let's look at a picture to be sure. Let's actually just go steal the Manhattan distance equation from somewhere, if it exists.
picture of it visually. That's Euclidean. Manhattan. Oh. So Manhattan is like not Euclidean. So ours would be this and this would be our Manhattan. Oh, and here's even a little formula. We'll just, I mean, it seems obvious enough, but I'm gonna make this into a function right now. And let's just make it a big map. So I want to do it like this. Start. And then I'm going to, this have me an XY coordinate. Keys. Oh, actually like this. X1, X. Y1, Y. And then X2, X2, Y. So it's, you give it a start and an end. We destructure them right here. And is math not a, if there was an absolute value under like a library called math that was just available in Clojure Core. Yeah, okay, there is, but it didn't like my first try. Actually, that's not even the first part of this. We're going to be adding them together, right? And then we're going to be subtracting here. I'm just going to indent this under. It's easy to read. And then the second one is going to be y. It's y2. Manhattan distance it is. Okay. We'll go ahead and call this. Something really easy, like we just moved one. Because usually what will happen here is I might discover I made a typo that I'd look past if I didn't try it. Come on, spacing. That's what I would expect. Okay. And then we need something to describe moving through these actions, and that should just be reducing over them. And what do we want to finish with? Well, we need a start and an end. No, we just need the end, because we have the start. It's always 0, 0. I think. I mean, yeah. So really, could we update it every time? Yeah, because you think the sum of the, but we shouldn't output the sum. We should output the last location, because that'll just be easier to check.
we're gonna need to keep track of the previous location. So the current location, no, I guess we will. Yeah, the last location. So it's just gonna be the current location. So in which case we need to know our heading, which they said we started with east, which is an E key. And an XY coordinate, I guess. Yeah, that would be right. That's our location, starting location. And then every time we'll just be updating this. I'm gonna call this CX and CY. Current X, current Y. Because that's not necessary. Also, it wouldn't work with keys, but I'd have to destructure it the other way. And then this part should be action and value. And so, let's just think about our first one. F10 would move the ship 10 units east because the ship is facing east. So we're gonna have a case statement here. And the first thing we're gonna handle is F. And in fact, we're only gonna consider F to start. I'm just gonna take one, right? So what am I saying? I'm saying that our entire input just has to handle F. And then we'll just keep going. And then we'll add the other cases that aren't part of the input. F10 value 10. So basically, our heading wouldn't change. I'm just gonna. So you could also update. You could do as something, and then we would just update one or the other. But I think that it'd be better to be consistent here. Maybe just return a new one every time. Oh, and then this is interesting because we're gonna have to do like another case statement because depending on our heading, we have to. What we do here depends on our heading. I'm not going to start with that part. Yeah, let's do this. This is kind of awkward, but I think it's the correct. The other way to do this would be, we could make it flatter. I don't think there's really a big difference. In fact, I feel like localizing it is better. Because it's only an issue forward is going to have. So making all of the conditions care about it, I think would be a mistake. I mean, another way to put this is you could put this into a function. Like if it bothers you that it's like getting, like if it bothers you visually, that's not a good reason. It should be about like compartmentalizing the logic. And what am I getting at here? Well, what's the one we have? We have is east. So east means we're gonna have to add, because like west would be negative and east is positive. So heading doesn't change. It never will change. So that's one thing I could not bother to do here. We'll associate at the end, the heading. If that makes sense. So because the heading never changes with any of the options here, so putting it for each one would be misleading and error prone. So for heading east, we're increasing the x, so x. It seems like the thing to do is now to do this as something really small, m for now. Somehow I'm not case on the action. Yeah, I deleted that for some reason. And this should be all she wrote. Protocol, lazy sequence. Really? Okay. I mean, why would that be? This isn't right. Wait. Yes, it is. Wrong number of arguments passed to rain risk eval function. Oh, this is the wrong number of arguments. So reduce KV and is not what we want. So reduce KV does take 3 arguments. I didn't even, just wasn't connecting the dots right. I don't know if we need this anymore. And that's correct. So, and north is what we're going to handle next. So it's going to be n and 3. And in the case of that, we're just going to update m, and we just want to be, we don't change our heading. We wouldn't change x, but we would change y, right? Copy this guy. No, not FF. Because we headed north. And then I feel like we can safely fill in the rest of these. and then we'll have to consider the cases we didn't do. Should be really obvious. 4 with 7. So we need to fill in all of the directions here. I'm gonna copy this line and change all of these. Some redundancy here, I guess. West, north, south. Let's split this off because we already did this one. These ones need to be changed. And then if you're going west, it would be X. Just be subtraction if you're going north. I'm now switching Y, and it would be addition if you're going south. It would be Y. We're going to subtract. Okay. And then this is the same thing again. You see what I'm trying to do here? Just thinking about simplifying this, but honestly, if this is the end of the road, for now, I might not worry about it. Let's at least get it to work. Because it's, because you could put those in a function and then just, instead of action, you know, heading, except for F. New matching case R. Oh, we forgot about left and right. I forgot about left and right. What the heck does left and right do? Oh, it's always, I'm assuming it's always 90 degrees, because otherwise we have no, like, northeast. So I'll never, heading will never have this. So basically we just have to do another case statement because it's like on the value, because it's either going to be 0, 90, 180 or 270, I would assume. What does our actual input look like? 180, 180, 90, 90, 90. Left. 270. There's a left 270, so I'm pretty positive. Oh, there's going to be left and right. LOL. Okay. So they're just trying to drown us in case statements. They're like, let's see how well you can keep track of things. But it won't really matter. I think it's just like, maybe it's one of those like test of endurance questions. Oh, if I say that and then let's go watch, we'll go look up another answer. Somebody else doing it, the one line of code, because there's like some formula. It doesn't seem that way right now, though. Zero would be nothing. Turn right 0 degrees. Are there any like that where there's 0? No. I see where this is going to get uncomfortable, because I'd need a case statement for each one. Because if I'm facing east and I turn 90, I'd be facing north. If I'm at north, so we'll want to keep track of the degree we're at. Knack up based off the direction as well. And just link those two together. So what I mean is, and we'll always do modulo on yeah. So 0 is going to be east. 90 is going to be north. 180 is going to be west. South. So basically what's going to happen is we're gonna also keep track of our not n, let's say our deg to dir, not directory direction, our degree, which is, I guess this would be redundant with heading. What am I trying to do? Because what I'm saying is that, like, if we're heading east and we get a what's our first instruction here? Right 90, then what's east for you guys? I can't do this because it's reverse. So you know what I mean? You're gonna like curve upwards east, and then you're gonna be at 90, which is north. As or if it said left, we would know that 0 is also 360 in the problem, and we would subtract 90 and then get south. So is heading redundant? Probably, yeah. Probably what we want is a
Oh no, I guess we don't. We could do it the other way where it's direction to degree. And then do the math. We don't want to keep track of both. That's what I was trying to get at. So go ahead and reverse this. Okay, so now if we get, let's say our current heading is, let's do the one we've got. Because our heading's east and S is turned right 90. So what we do in the case of right 90, we have to know that, well, the brain dead thing is, first, direction to degree on our heading. Let's call this heading h to degree. Now that we're more certain. It's 0. And what we know we want to do is minus this by 90, because it's right. And that gives us minus 90. So we've got two things we need to do here. One is we need to always get back so that we get to 270. Like, we need to get it so that we get to 270. So it's going to be 360. Like, what, mod? No. It should be an absolute. No. We have to, 0 just has to be treated as 360. Always. So if it's right, 0 should be 360. And if it's left, it should be 0. And is that the only one? If we do 270, no, because this would be effective problem. I'm gonna take a break. I know what we have to do. I just now I know for sure I need to get out a pen and paper for a second and do the math. It's gonna be something modulo. Okay, so I just sat back down and we were thinking about how to handle this right and left, and I feel like I need to not get ahead of myself, and let's make sure we're drawing this out right. And then I will probably take a little bit longer break to go walk my dog, but I'm have an inkling that the second I draw this out, it's going to be a little bit weirder than I'm thinking. I don't know why I'm making these so far apart. So visually, say we're heading east. Yeah, already I got it. Because look, what color do I want here? Just a different color. So this is going to be right from this location. This is going to be left to get to that one. But then if we do that, this isn't a good way to do that. I mean, that is the direction we end up facing. But what would it do? Let's just do transition. This is like really obvious, but this way, and if we go right, then let's say this is 0 and this is the next stage, with right as the action in between, then we're going here. And then if we went I have to orient it towards myself, because now if this is my head and this way I'm facing, this is my right, and this is my left. So right again would be there. Yeah, that's just obvious stuff. So, in there. Okay. So you would just keep, so right is obviously just like that, dummy. And then left is always the other way. So you would always end up getting to the same place. You know, like it wouldn't change depending on, if you're going east and you take a right, you always end up at south. Yeah, 'cause this is right and this is left if your head's that way. Okay. Nothing to see here.
So what we found out last time is more or less like I've written down here on the right. That just based on the heading and the degree, we just have to treat 0 differently. And there might be some unifying way to do this that would be nice to capture here, but the first thing that comes to mind is really, well, is it just 0 because if we're at 180 and we get 270, when it result in something 2? Yeah, so we always need a way to, because 180, and then if we're told to go to the, some direction of 270, we'd have the same issue too. So like 270, so left in this case by if our order is left by 270, then it's going to be, and left is typically addition, then we're getting 180 plus 270, and that's going to end up in, hold on. Okay, so what were we doing? Oh yeah, so, right. It's going to be modulo 360 because, like, what, you know, kind of what we've done here is we've taken a repeating cycle of 360 degrees and we're just modifying it. We're taking, you know, we're saying like what we need to normalize it back to within 0 to 360 degrees, and that's what modulo does. At least that's my high level version of it. And so it's going to be that going to the right is always subtracting. Yes, because 360 subtracting. So right is always subtraction. So let's just capture that right away. Let operator if, oh, this also needs degree heading. I don't want to say action. L or F. It's kind of silly. Let's just say action, I guess. This name is too long. It's because I'm just like sketching things out. We've only got 2 options here. So if this action equals left, let's say right because it's always subtraction. Then that's, otherwise it's addition. There, now we just kind of get that out of the way. That's pretty ugly, but it's out of the way at least. And then what we're going to have is this operator and then our current degree not our current degree. Yes, our current degree, which is our heading to degree. and then the value. Okay, this is too many things. I'm gonna put these all in here. And I'm just gonna call this M for now, because I'm pretty sure this function's gonna get tossed in some form. And then all of this is going to get modulo 360. Oh boy. So let's see. Heading. So if we're at what's the easiest one is 0 to 90. So we're heading east. We're gonna go left. So our action is left. And degree is not a thing. Degree is our heading. And our value is 90. So I expect is to get back right now. It won't get back a new heading. It's going to get back 90. So we do need degree to direction. Which we made. Man, this really just feels like an endurance test, doesn't it? Okay, so let's try right, and I feel like if right and left works, now what do we expect? We're gonna go to the right by 90, we're starting east, which is 0, so we want south, which we get. Let's try a bigger one, and then I'm gonna be confident. Let's say 100 and, what do I mean a bigger one? Let's just try a different, so we're at 180. Which is west, and if we go left, no, we want to, I'm sorry, it's not west, I keep jumbling this bad. If we're heading west, and our action is, let's say left, and we do that by 180, then we should end up back at east. Should we do, if we pump this up to 270, should we go north? Everything seems right in the world, if just a bit more code than we had hoped. So then, we've got this case statement going. And these are kind of handled the same way. So we're just gonna use our created function that wasn't a function that wasn't really created in this. Right, and then we're just gonna soc. Oh boy, and we called this M2. Let's just dump this. I mean, right now only we understand how this, like handing this code off would be problematic at the moment, but we've got too many other things to fix to worry about. So basically we're going to be updating the heading with the new heading, and we're going to be passing this heading action value. do something a little bit awkward here. Because it's like, I feel like I think like now we're done. Now we can compute the answer. And I think that the fastest way to check that we're on the right track here is to get our Manhattan distance, right? Let's just plug in our numbers. Like, now I'm not gonna even destructure this. So, start is gonna be x0, y0, and then end is gonna be 17, y negative. Yeah, that works. You can have a negative number. 25. That feels like a number that I saw on the screen. It is. Starting position is 7 plus 8. 25. Okay. So now let's turn this whole thing into a function. It's like how much destruction do you want to do? Because we could just do basically this should work because it is the end, and it does. So now we just need to pass in a different file for our answer. Basically removing the word input. 1148. That's the right answer. Okay. Like last time, I think what I'll do. Actually, should we learn from our mistakes? We should. We should always learn from our mistakes. That was a dumb question. I refactored just to independently talk about why you'd want to do certain refactors. And then I just kept mentioning that like it probably wasn't a good idea at this point because the problem is going to change too much. But I mean, and also we know that change is something we're going to tackle right away. So like it was, and we're going to be doing it. So all of those things combined meant that doing it right then and there was bad. Now if like I knew that I wasn't going to be touching this for a bit, or wasn't clear that it was the case, then those refactors would have been good because I coming back later would have had a much easier time changing the code after than before to the new thing. But as it was, it didn't really make a big difference in what we had to do next. Or maybe it did. You know what? I ended up not really coming up with a solution that was like way better than what I had. So maybe that's not true. It's just, you know, you never know. Okay. Till next time.